Today I would be talking about Dart on Cloud Run. And let's go in presentation mode. Okay, so this is my introductory slide. So the topic for today is Dart on Cloud Run. So about the author, so I am a lead one software engineer at UST. I am the creator of Flathead with Flutter. It's a website where I share my experiences on Flutter. I am also a writer at Flutter Community, which is a Medium tech publication, a YouTuber, blogger, and also an event speaker. Next, now let's see how does a simple Dart program look like. So on the right-hand side, there is a snippet of a small Dart function. The name of the file is main.dart, and every Dart program enters using this main function. And inside this main function, we have this one line, which is a print statement, which says hello Singapore. And if we run this program, which is done using Dart run and name of the Dart file, in our case, it's main.dart. Once we run this file, we get the output as hello Singapore. So this is the overview of a simple Dart program. Now let's see what's Cloud Run. Cloud Run is a managed compute platform which is used to run and scale containerized applications. So this is one of the products which comes out of the box from Google Cloud Platform. And since it's one of the product of Google Cloud, so it's entirely managed by Google infrastructure. All the heavy lifting is taken care by Google team. You don't need to worry about anything. The only thing you need to worry is getting your code running. And also it automatically scales up and down to 0, depending on your traffic. So if your team is having a peak load and the traffic is high, it would automatically scale up your instances. And the days in which you don't have any traffic or less traffic or even no traffic at all, it automatically scales down to 0 also. Some key features of Cloud Run. So firstly, we can use the programming language of any choice. So if you're comfortable with Dart or JavaScript or Node, just containerize, just create your application and use Cloud Run to deploy it. Second, we only get paid when our code is running. That means, and this is built up to the nearest 100 milliseconds. That means if our containers or if our instances are not running, we don't pay to the Google. Lastly, it fits well with the container ecosystem, as we know, like Cloud Build, Cloud Code, Artifact Registry, Docker. So since these are all familiar names with the containerized world, like Docker, Cloud Build. So Cloud Run fits in well with whatever container ecosystem we have already. Now let's see what are the steps to use Dart on Cloud Run. Also, a prerequisite before these 3 steps is you need to have a GCP project. GCP means Google Cloud Platform project with billing enabled. Now let's see step by step. So first step is we write the server-side application. The second step is we containerize that application with Docker. And finally, we deploy our container to Cloud Run. Let's see these steps in detail. The first step, write server-side application in Dart. So for creating server-side projects in Dart, we use this command, which is dart create -t server simple dart-conf. So in this command, let's see what this command means. -t stands for template. Server simple is one of the templates which comes out of the box from the Dart language. And dart_conf is the name of our project, which can be anything depending on your use case. And at the bottom, we can see there are the number of templates available from the Dart currently. So these are 5 in number, and one of them is server simple. And if we see the description, it says it creates a web server built using package shelf. Now let's see this in detail. So on the right hand side, we see the template which we used in the previous step to create our server-side application. And these are all the files which we get out of the box. Minimum set of files which we need to run a server. So we notice there is only one server file, one .dot file called as server.dot. In the pubspec YAML, there is a dependency called a shelf dependency, or it's a package called a shelf. And what is shelf? It is used to create and compose web servers or part of web servers. This shelf package is also available on pubdev. Now, we see on the right-hand side, how does a server.dot file look like? In the first line, we have instantiated port as 8080. In the next line, we are using shelf package, which, as we saw in the previous step, is already present in our server.dot. So now we use cascade, which is a method in the shelf package itself, to add the routes. So these routes are added using cascade. So what's a cascade? It's a helper that calls several handlers in sequence and returns the first acceptable response. So what I mean is all the routes, so any server-side application has some routes which it exposes to the outside world. So all those routes are present or bundled in our app routes file. And this is all bundled together using Cascade. We'll see later how does this app routes look like. Now let's see what does this io.serve look like. In the previous slide, we saw we have all the routes bundled with Cascade. We have instantiated or we have initialized our port as 8080. The last thing is we now want to start an HTTP server, which would help us in serving our application. So that is done using io.serve. io is a method which is also present in one of the files of shelf package. This serve method takes in 3 parameters. So the first is it takes in a handler. Next, it takes in the address. And lastly, it takes in the port. So in our case, the handlers we described in the cascade. But to get the handlers out of that cascade, we use the property cascade.handler. Next, we have specified the addresses of type any IPv4. Finally, the port which we initialized as 8080 on the first line of void main function. So this all bundles together and we serve our HTTP server at which is categorized or which is identified by this print statement serving at http:// server address host and port. And adding to this, if we want to log a request for all the handlers, we get that functionality out of the box from the shelf package log request method. What we do is, as we have specified all our handlers, we just wrap this call with log request. So in short, what it does is it logs all the requests on top of our handlers. We'll see this in action as we go forward. Now let's see, how do we define routes? We define routes using a package called the shelf_router available in pubdev. On the bottom, you can see a tiny snippet of how does a route look like. We create an object from this router class, called it as app, and we use the method get from this app, and we specify the route name and a handler. So in this case, the route name is /hello, and the handler itself is defined inline. And what it does is simply returns the response as, hey, hello world. Now let's see this in a bit more detail. The get method, which we saw previously, it comes itself from the shelf router package. It takes in two required parameters, a route and a handler. Whenever this route gets hit, the server responds using the handler. So these handlers can be customized based on our requirements, which we'll see in next slides. Adding to this, we also support methods, the shelf router package supports methods like post, put, delete also. So this is the app routes file in our folder, in our project. So we have this app routes file class. We have a method called as routes. And in this routes, this method returns a router. And in this router, we have three endpoints defined. The first one is a get endpoint exposed as /hello world. Another one is also a get endpoint exposed as /req info. And the final route is /post name, which is of type post. All the handlers associated with these routes are mentioned on the right-hand side. And now let's see how do we define handler in a bit more detail. So handler. On the right-hand side snippet, we see this is a handler. The return type is of response. In this case, we return a response OK. And this OK, in this OK, we specify the string that, hey, Privyat from startup 2021 conf. Now, every handler is associated with an HTTP request. As we can see in the hello world method, we have a parameter of request. So when this handler gets hit, which is /hello world, so the response which we return from this handler is response.ok. And the same, we see the handlers which are defined in our app. So we have a class called as app handlers. In this class, we have three handlers defined: hello world, req info, and a post request. All these handlers take in the parameter of type HTTP request. Now let's see how do we extract data from the request. So as we saw previously from the handler, we get this request parameter. For extracting header information, we can use the headers method from this request parameter. And the request.headers returns us a map of string. So from this map, we can extract the defined or the desired keys or the values. In the next line, we create a response, and this response is also of type map. In the first, we extract the method from this request parameter, and we map it against the method key. In the second key, which is host, what we do is the headers which we got from the request headers, we extract the host key, and its value is mapped against the host key of response. Now we want to send a response back to the client. And in this case, what we do is pass the response as JSON. So the above response body is converted into JSON using JSON encoder. This comes out of the box from that. And we say that, hey, this response is expected to be of type JSON. So we add headers and specify the content type is of JSON. Now let's see. This was how do we extract parameters from the GET request. Let's see what happens in case of a POST request. So for POST request, every POST request is associated with a body, post body, I would say. And we extract that post body using requests.read as string. Next, we extract this body and map it against a variable called as body. The next step is we map this body, or we convert this body to a request model, which is basically a data model. So from this request body, we extract the name parameter. So basically we are sending a post body as name, which we will see later on. So in this, the third step, what we do is we extract the name parameter from this request body. We create a response model, which we expect to send back to the client. And this response model has only one parameter of type message, and we construct what we need to pass back into the client. And finally, this is instantiated in a variable called as response body. Finally, this response body is converted to JSON using response model to JSON. And we again specify, hey, client, the header or the response type you expect is of type JSON. So we mentioned the content type to be application JSON. So till now, we saw how did we create a simple server-side application. Next step is we need to containerize this application. Let's go deep. For containerizing the application, we make use of Docker images. Since the server application was programmed in Dart, and recently it was announced that Dart is now available as an official Docker image from the Docker Hub, which is a place where you would go and find all the images for any language. So this image, what it does, it supports ahead of time compilation and helps in reducing the size of build containers. And if the size of our containers are small, which in turn implies the speed of deployment to cloud environments would be fast, which is the third step, which we see here, that improves speed of deployment in container environments, for example, Cloud Run in our case. Now let's see. So for containerizing any application, we need a Docker file. Same, we will create a Docker file in our server application. In this Docker file, we would need to put some commands which would help to create a container image. Those commands we can copy from the .docker readme available from the Docker Hub, which we saw in the previous slide. And internally, what the image it uses to construct that final Dart application is Dart:stable. Finally, we also create a Docker ignore file, and the contents from in this Docker ignore file are also copied from the hub.docker readme. Now we have our Docker files ready with all the commands in it. Next, we need to build an image. So that is done using the command docker space build space -t .upconf2021 period. Here, .upconf2021 is the name of the final image which we are creating. This can be anything, whatever you want. Once this image is created, we can test it also locally using the command docker run -rm-it, which stands for interactive terminal, -p, and here we map our container port with our application port. In the container, the port exposed 8080, and in our server application, we also expose the port 8080. The final parameter followed by the port is the name of our image, which we want to test. Note, one important thing is before doing all these Dockerized stuff and all, we need to have installed Docker software on our machines. Now, let's see the final step, how to deploy that container image to Cloud Run. So just a recap, in the first step, we created the data application, the server application. The second step, we used Docker to create a container image. We created the container image locally We tested it locally. Finally, we now take this container image and deploy it onto the Cloud Run. This comprises of 3 steps. First, we build and store the container image in GCR. GCR stands for Google Container Repository. The second step is in this GCR, basically we store our container image. The second step is we take that container image from the GCR and deploy it onto Cloud Run. And if these 2 steps are successful, we get to see the final service URL, or as we know, a HTTP endpoint exposed to the world. Let's see these steps now. Before we see these steps, there is a prerequisite that we need to have Google Cloud SDK installed on our machine. And we need to authenticate gcloud. That can be done using the command gcloud auth login. So once we run this command in our terminal, we get a web page is opened in our browser, and we are required to authenticate our SDK or this gcloud. If everything's successful, you can see this message on the right-hand side. You are now authenticated with the Cloud SDK. Next thing to do is we need to set up our gcloud project in which you want this container to be exposed. For that, we first list our projects using gcloud projects list, followed by setting up our project using the command gcloud config set project, followed by your project ID. In case you're not sure of your project ID, just fall back to the first command gcloud project list, take your project ID and paste here. Now comes the real part. In the prerequisites we saw, we have set up our gcloud project where we want our Cloud Run image, where we want to expose our Cloud Run. Now comes the first part where we build and store the image. In the step where we created the Docker image locally, and we tested locally. Remember, it was just locally. We now need to publish this image in Google Container Registry, or aka GCR. That is done using the command gcloud builds submit -- tag followed by gcr.io, which is the command to recognize GCR, followed by the GCP project, which in case is FIR sign-in. This is my project basically, followed by the container image name, datapconf2021, which is the same image name which we use to create locally. Now, next step is, now we have our image in our Google Container Registry. We now need to take that container image and deploy that container onto Cloud Run. This can be done using gcloud run deploy, which is a command used to specify that this deployment is done on Cloud Run. So in the command, we see gcloud run deploy datapconf2021, which is the name of our service, followed by the image, which we say that, hey, our image is present in this container registry at this path, which is gcr.io/project name /container image. Followed by, we set the region to US Central 1 in our case, and since my application doesn't need any authentication, I set the flag to allow unauthenticated. And if the deployment was successful, the last command was successful, we see that, hey, deploying container to Cloud Run service in project blah, 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 it's done. Service is up and running, serving 100% of traffic, and we are given with a service URL, which is, in my case, it's a datapconf2021 / something.a.run.app. Okay, so it's time for me to show a demo. Hope the demo gods are with me. Okay, so we will see the application, this service URL, which we have got from the Cloud Run successful deployment. And this is our Cloud Run server application. Let me reload. So this is basically this is the front page of our server application. But the important thing to note here is there are 3 endpoints exposed here. The first one is /hello world. The second one is /request info. And the third one is /postname. Now, if I click on this, this should launch a new tab and we can see the URL appended as /hello world. The response from this endpoint is previous from data 2021conf. Now let's go back to our Cloud Run application. And there are 2 more endpoints, /reqinfo and /postname. But instead, let's hit this endpoint using curl, since we are programmers. I run this command using curl, and the response I get back is this. Now let's dissect how did this response happen from our code. So this is our entry point. So let me expand the files. So this is our entry point, server.dot. We have our port here, 8080. We use Cascade. We have our app routes defined here, app routes. Let's go to these routes now. So this is the class app routes. In this class, we have 3 endpoints defined: hello world, reqinfo, postname. And if we see here, reqinfo is the same which we saw here, reqinfo. Let's look at the handler for this endpoint, which is handler.reqinfo. So the first thing is we print a statement inside reqinfo. This is useful for us to log in our Cloud Run service, which we see in just a moment. And the response we get, we basically create a response: handler path, method, HTTP protocol, user agent, host, is the same response which we got here. And this was all using the request parameter, which we get it from the handler. We extracted the useful methods, handler path, method, protocol version, and finally, we created this response, send it back to the client, specifying this is of type JSON. Now, there was a last endpoint in our application, which is /postname. And since this is of type post, let me clear this. And we will again call a curl endpoint, postname. Okay, cool. Here we have mentioned the post body as name, and the body has a key name and the value as name, Aseem. So, and this is our endpoint for this post request. Let's hit it. We get the message, if this is visible, zoom in, which we get the message here, hey, previous Aseem from data 2021conf. Again, let's go back to this and dissect how did this response came. We again go to our server.dot file. We have our app routes defined. We go to our routes. We see there is an endpoint /postname, which is the same as we see here. And let's go to this handler, which is post request. The first thing is we again print a line just for our sake of logging purpose inside post request. Next thing, we extract the parameter from this request, read as string. And we save it in a body parameter variable. We construct a request model based on this body parameter. And we also do some checks that, hey, if in case our body name is not, the name parameter is null or empty, we send that, hey, we are expecting a name, please provide name, and this request is definitely bad request. But in a happy case, if we are provided the name which we saw here, So we create the response model. Okay, let me show you guys. This is simply a tag class, and we embed the name parameter which we extracted from the request body, make it in save it in a message variable in the response body, and send it back to our client and this response body which we saw here. Okay, now let's see what happens if we don't send the name. So this is the case of a bad request, and we should get the response as, hey, please provide name. And yes, we are right. We get a response which says, hey, please provide name. And this is of type bad request. But now let's head back to the server side of things. How does this logging and request look like in the Cloud Run perspective? So for that, we head back to our. So this is my Google Cloud Platform project, and this is my container registry. If we recall, the image name was dataconf2021. And so basically, if you click on this, so it comprises of different revisions I use to deploy it. But we don't need to worry about this. The important thing is our image is saved in GCR. Now let's get back to the Cloud Run. So in the Cloud Run console, we have different services, but the important service here is Startup 2021, deployed in region US Central 1, allow unauthenticated, just for my use case. Let's deep dive into this service. We see this service is deployed in region US Central 1. The URL exposed is this, which is the same URL which we see here. And if we head back to the logs, okay, it's loading. Okay, we see here the first API endpoint which we hit was hello world, and what the server side logged was, hey, what is the request method type? Okay, it's a get method. What is the response code? Okay, it's 200, and the endpoint name, which is /hello world. The second endpoint we hit was req info, and we see here that we have the server has logged that line print statement. If we can see, go back and show you. So this is the line inside req info. The method type, okay, it's a get method. Response code, okay, it's a 200. Okay, the endpoint name, it's /req info. The third request which we hit was a post request. Also, we have logged, the server has logged in that line, print line, which we see here inside post request. Okay, the method type, okay, is a post. Endpoint response code is 200. The endpoint name is /postname, and yep. And the last request which we made to this endpoint was without a name parameter, and we expected of a response of type bad request. And generally, bad request is 400. So that response was the line was hit, it was printed, the method type was post, the endpoint, the code was 400, and the endpoint name was postname. Now let's see one more case where we don't provide that entire JSON body. So that's the case. So basically, we have wrapped all this declaration of handler inside a try catch, and if we don't provide the body, it would fail. And okay, first let me remove the body here, and it would fail here, go in the catch statement and give us internal server error, which should be of response code 500. And yes, we are right. We get the response as something went wrong, please try again, which we expected from here. And now let's go back to our server logs and see. So this was the last where we left off. We had a 400 and slash post name. Let's refresh this. The final request, okay, the line was locked in, but now we see this error message, error in post request, where it has logged in some details. And we go back to our server code and we see error in post request. And yes, we had logged in our exception in form of string, which is the same which we see here, error in post request. The post and followed by this, the endpoint is post, the code response code is 500, and the endpoint name is slash post name. The 500 is because of this internal server error. Okay, now this was in the server side. We can even run this application locally using the command dart space run space bin slash server.dat. Why server.dat? Because the name of my file is server.dat, and which is the entry point of any Dart application, the main. Let's run this locally. It says serving at this URL. Let's open this URL. It's same thing, same image, same endpoints. But we see here, we get this additional benefit of the timestamp and the method type and 200, which is, so all this is possible using this log request, which we added in the first place to all the handlers. Oh, sorry. Cool. Now let's call this endpoint hello world. And we see in this case that, okay, so this is slash hello world being called. If we head back and call in the req info, we get the response like this, and we should see the same print line and the same, yes, we see inside req info, and the same method type, response code, and the endpoint name. Okay, let me stop this. Remove this. Cool. Also, all this deployment is taken care of using, we have created a make file, and in which we have placed all our commands. If we have make deploy, make deploy is the only command which you need to containerize this. It creates an image, creates a GCP build, and deploys onto Cloud Run. And all these commands are explained here. So what make image does is this, it builds the image. What GCP build does, it creates an image, stores the image in GCR. And finally, GCP deploy, what it does, it takes the GCR image and deploys onto the Cloud Run. Cool. Now let's head back to our slides. Cool. I showed you the endpoint. I gave you the demo. So what lies ahead? We can, the Dart team has taken a step further and have created a framework called as functions framework. What it does, it's basically an open source function as a service framework for writing portable Dart functions. Important thing to note is, without needing to write an HTTP server or request handling logic, we get our endpoint URLs, which we can see here on the right-hand side snippet. So in this snippet, we have annotated a response handler with @cloud function coming from functions framework. And the handler defined here is just response.okay hello world. And once this gets deployed, we get our HTTP URL and we get that URL automatically using this @cloud function internally using the functions framework. No longer need to care about the routes, no longer need to care about the middleware and all. It just happens out of the box from this function framework. Cool. Now, everything has a good side and a bad side. Now that's the time for this presentation and for me to show you pros and cons. Pros. You don't need to learn a new language for server-side. You can reuse the existing business logic from the app or client side. Dart on server is also gaining traction from the community. And also a server-side framework, a complete framework, Conduit. I don't know how to pronounce it, but I'll go with Conduit. It's undergoing development. On the right-hand side, you can see the snippet of Conduit package available in PubDev. Also, a Reddit comment by KevMo, who says, "Hey, super excited to see folks talking about Dart on the server. I've cared about this space for a while." And when he says cared about this space for a while, he means from 2014. And who's KevMo? He's the product manager at Google Dart team, taking Dart in cloud. And now let's see the cons. Dart is not mature as server-side languages like Go, Node.js, etc. Second, there are not enough real-world-based packages like database support. Mostly server-side internally communicates with your databases, Mongo, MySQL, Azure, Dynamo. Hopefully I've covered all the big guys. Next, and so there are not enough these like support for these databases. This is just an example of real world packages which a programmer wants to use in his or her day job. Thirdly, Dart is still being used primarily because of the Flutter framework. Now, next, there were server-side frameworks before the Conduit, Aqueduct, and Angel. Both the repository are archived and are no longer maintained. And lastly, there is no big name associated with production server-side code in Dart. So currently, there is no a big name as of now who would say, "Hey, we are using Dart from the server side." Cool. So some of the links which I saw could be meaningful to you guys. Left-hand side, this is a YouTube talk by Dart in the Cloud, and this talk has Kevin Moore, who's the product manager at Google Dart. On the right-hand side, there is a Medium article which explains writing server-side Dart code. The developer says his experience, and you guys can go and have a look on this. And the bottom right side, you can see what's the current state of server-side frameworks for Dart, which is a Reddit post. Some useful links for you guys to try out. Cool. So now the source code for this tutorial, not the tutorial, for this presentation is present here on this URL. And you guys can also stalk me at YouTube, GitHub, Twitter, Medium, and the website Fluttered with Flutter. And with this, I can say that's all, folks. The floor is open to questions. Over to you, Valentina.
Thank you very much. I really enjoyed your presentation, and I love that you added the cons and pros slides that actually made a lot of things clear. And yeah, I have a couple of questions for you. Like some of them are for clarification, and the last one would be a funny one. Okay,
cool.
so for clarification, so you said that there is an official Dart image, and does it use only the stable version of Dart, or can you specify and use the older version?
So currently that Docker image uses Dart stable. That's actively maintained by this Dart Docker community. And internally, maybe they can use, I don't know what image, like what version they use, but as long as that's stable, right, we don't need to care about that. Heavy lifting is done by that team itself, yeah. And I just saw today that image was updated. So yeah, before this presentation, I had to update it.
Okay.
Cool.
Okay, the next question, I noticed that you had to specify the region when you were deploying the container, and it just looked a bit unusual to me. Do you know why you need to do that?
So generally, right, gcloud commands, they give you an option to specify what region you want to deploy. Let's say if I didn't have mentioned this, right, if I was running this command, it would have stopped me at some point and it would ask me that, hey, which region you want to deploy in. So there are 24 regions as of now, and depending on your use case, you can deploy it any region. But yeah, you have to give that region. Yeah.
Okay, now to the funny/stupid question. So you have your own website, Fluttered with Flutter, and the question is, do you use Dart for server there?
Uh, no, but recently, just for small POCs and all, I create these small endpoints, and yeah, that's it. But my website is not using that. Yes, irony.
Okay. Well, okay.